Hello there. In today's video, I'm going to be explaining what mathematical induction is. What I'll also do is provide you with one example of how to use it to create your own proofs. So, what is mathematical induction? Well, it can be used to prove whether or not general statements are true, commonly for positive integers, n. When producing a proof using mathematical induction, the following 4 steps should be applied. Namely, the basis. This is where you demonstrate the general statement is true for n is equal to 1. Number 2, assumption. You assume that the general statement is valid for n is equal to k. 3, the induction phase. This is where you demonstrate the general statement is correct for n is k plus 1. And finally, number 4, there's the conclusion. This is where you state that the general statement must then be true for all positive integers, n. Now, there is something you must take into account with mathematical induction. Unfortunately, proof by induction will be of no use when trying to derive formulas from first principles. However, it can be used to see whether or not a general statement is correct. So what I've done here is summarized what mathematical induction is using the book Edexcel AS and A-Level Modular Mathematics 2008, page 136. If you're interested in this book, you can find a link to it just below this video. So let me show you mathematical induction in practice. What we're going to demonstrate is that 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed plus etc. plus n cubed is equal to a quarter times n squared times n plus 1 squared. So this over here is our theorem, okay? Now, how do we prove it using mathematical induction? Well, we first make n is equal to 1. And this will give us, for the left-hand side, 1. For the right-hand side, we also get 1. Now, since LHS is equal to RHS, the summation formula is true for n is equal to 1. So that's the basis out of the way. Now let's go to the assumption. Now we have to assume that the summation formula is true for n is equal to k. So what we get is this formula over here. Now, using that assumption, we can imagine what n is k plus 1 is going to be like. So the summation formula becomes this over here, which is equal to a quarter k squared times k plus 1 squared plus k plus 1 cubed. Now this over here is the induction phase, and if all goes well, after you've manipulated the equations or the expression, what you should get is k plus 1 replacing n, okay? So what you get is this formula over here, but instead of n, you're going to have k plus 1. Now if you get k plus 1 replacing n, like so, you can then say, therefore, the summation formula is true when n is equal to k plus 1. And this is the induction phase out of the way. So, how would you finalize your proof? How would you conclude it? Well, you'd write, if the summation formula is true for n is equal to k, then it is shown to be true for n is equal to k plus 1. As the result is true for n is 1, it is now also true for all n is greater than or equal to 1 and the positive integers by mathematical induction. Now, to make things even more fancy, you can put the square here to demonstrate that you've completed your proof. So that is mathematical induction in a nutshell. If you'd like the workings, just click the link below this video and you'll find them there. If you found this video helpful and you want more mathematics proofs content, make sure you're subscribed to my channel. Thanks for watching, and I'll see you next time.